Bismillah Rahman Rahim. Welcome to my channel Learn Math with Sayyid Ali. One of my 11th grader has sent me this question. A bacteria culture double in size every 30 minutes. If there are 200 bacteria in the culture, now how many will be there in 5 hours? So I repeat the question. It's very interesting to solve these questions because these are called decay or growth questions, right? And we have done for the last 3 videos the decay and growth of a exponential function. And what we did was exponential function of the form y is equals to c times a to the power x. This is exponential function, and this is also called decay or growth formula. So whenever there is a decay or growth in the question, you can use this formula, growth formula. So now we know what is decay or growth. Decay means decreasing, growth means increasing. A bacteria culture double in size every 30 minutes. If there are 200 bacteria in the culture now, how many will be there in 5 hours? Right? So formula is y is equals to c times a to the power x, where we define that y is the end amount or ending amount, right? Whatever is the ending amount. So ending amount means he is asking us how many will be there in 5 hours. So he wants y after 5 hours. C is the initial amount. C, variable c, is initial amount. So when they start, so there are 200 bacteria in the culture. So when they start, initial amount is 200, right? So I will write 200. Let me replace the pen. So initial amount, right? So you have to remember the variables. Initial amount, right? So initial amount is 200. Very good. So C is the initial amount. A is the growth or decay. A is equals to growth or decay rate. Rate means, so A is equals to 2, where culture double, right? It's increasing, it's growth. So here A is equals to 2, right? It's a growing or increasing function because the bacteria is doubling in size every 30 minutes. Every 30 minutes they are doubled. If there are 200 bacteria in the culture now, how many will be there in 5 hours, right? This is the question. So we are setting up our variables, what my x is, and my x is number of the period. Number of period. What does it mean? Number of period means experiment time divided by GD time. So experiment time. What question is saying again? Experiment time means he's saying every 30 minutes they are doubling. How many will be there in 5 hours? So experiment time is 5 hours. But I need minute because the size is doubling in 30 minutes. So my question is in minutes. So I will convert this 5 hours into minute times 60 and divided by 30, because every time in 30 minutes they are doubling, right? So that will comes out as 10. If they would be doubling every minute, then we don't have to divide by 30, right? Then that will be the straight away, right? So that 30 minutes. So this is all 30. So this was 35 hours means how many minutes, and then divided by 30 minutes. Correct? Now we can plug it in the values. What we have, y is equals to, we can solve it here, y is equals to 200 is my C value, 2 raised to the power 10 is my x. So I will simplify it. It's equal to 204,800 bacteria. After what? After 5 hours. Answer. So calculation is not that much difficult because you guys can put it in calculator to get the answer right away. But the setup of the variables and the value of the variables as described in the word problem, we need to pick that up. A bacteria culture double in size every 30 minutes. Double means twice, right? And that is growth. A is equals to 2, double. So A is equals to 2. Every 30 minutes is here because when we have a time, the time period is x, but we have to see what is the format of the time period. So 30 minutes and 5 hours. Experiment time divided by whatever time is given in terms of the growth, right? We call it growth or decay time. Growth or decay time means whatever is given, right? So growth or decay time, GD. Sometimes we say that it is divided by experiment time divided by GD time. GD time means growth or decay time, right? Whatever the case. In this case, I have this growth time, right? 30-minute growth time. They double the size every 30 minutes. If there are 200 bacteria in the culture now, so initial amount is C, which is 200, and ending amount is Y. So you just plug it in the values in the Y is equals to C times A to the power X, and you are done. Another type of the question is asked in the same sense that an isotope of radium or radon or anything radium is made by a hospital or is used by the hospital, So it's a radioactive substance used by the hospital, right? So for cancer radiation, for what? For cancer radiation. For cancer radiation. Okay. The half-life of the isotope is 1620. Half-life. Now is the half-life is the term which is saying that it is decaying. The function is decaying. The half-life of this isotope is 1620 years. If isotope initially has 10 milligram, if isotope initially has 10 milligram, how much will they have after 50 years? How much will they have after 50 years? So this is the question. Why I quote this question here? Because the student who is asking for doubling the bacteria culture is like a increase, growth, right? So we term growth, we use the term growth here. But this time the isotope of the radium is used by a hospital for cancer radiation. Half-life of this isotope is 1620 years. If isotope initially has 10 milligram, how much will they have after 50 years? Same type of question, but we have to set up the data to use the same formula. Here, Y is unknown, right? After 50 years, what will be the quantity of that isotope in the hospital? So, C is 10. What is C? Initial amount. That is 10 milligram initial amount. A is 0.5. Why? Isotope for cancer half-life. Half-life means it always reduces to its half. 0.5, right? 0.5. Always reduce to half. Like if half-life is 1620, that means one oral question can be asked. Okay, this is the half-life. How, and I have initially, or hospital has initially 10 milligram. How much they have after 1620 years? After the 1620 years, how much they left? Half-life. So 5 mg is straight away the answer, right? But here they are not asking us that how much of it will be left after 1620 years. They are saying that how much of it left after 50 years. So my x is interval, right? So x interval is 50 years, but my half-life is 1620, so it's a fraction of 5/162. So you have all the data set. Now you can plug in the value, the same formula, y is equals to c times a to the power x is our exponential function for growth or decay. And my y will be equals to 10 times a, which is 6.5, which is 0.5 to the power 5/162. And if you put these values in calculator, you will get 9.7883 grams. So after 50 years, they will be having 9.788, right? Because the half-life is great for this isotope, 1620. 1620 years is half-life. So after this many years, the quantity will be half, as I told you in the beginning, right? 5 mg, from 10 mg to 5 mg. But they are asking us that how much quantity will they have after 50 years. So after 50 years, they will be having 9.7 grams. So hope you like the video. If you like it, subscribe my channel, press the bell icon button to get the next video. Thank you for watching.